Jupiter's biggest moons were discovered 400 years ago by Galileo. Io, Europa, Ganymede, and Callisto are fascinating worlds. Some could hide oceans that might hold life. Now, NASA reports that the Juno spacecraft has detected an FM radio signal coming from one of these giant moons. Where did the signal originate? How did NASA find it? And what other secrets are Jupiter's moons hiding? Hello, and welcome back to Z. Recently, something happened that caught everyone's attention. NASA's Juno spacecraft, still wandering space, picked up an FM radio signal coming from Jupiter's moon, Ganymede, for the first time since it was launched. This is the same type of signal you would find on Earth, known as Wi-Fi. Did we just receive an alien radio station broadcast from Ganymede? To figure that out, we need to learn more about this icy alien world. Ganymede is the largest moon in the entire solar system. If it orbited the Sun, it would be a planet, being larger than Mercury. Though Ganymede lacks an atmosphere, it's the only known moon with a powerful magnetosphere, which sometimes produces auroras affected by the moon's underground saltwater oceans. The aurora's rocking gives researchers evidence that Ganymede's underground oceans are possibly liquid and very salty, much saltier than Earth's oceans. The FM signal from Ganymede originated from electrons in electromagnetic fields, a process causing the electrons to whirl and oscillate much slower than their spin rate. Juno detected the 5-second radio burst in late 2020 when the moon crossed a polar region of Jupiter where the gas giant's magnetic field interacts with Ganymede. So, could there be life on Ganymede? We know the signal didn't originate from alien life. Ganymede is very cold, with temperatures around -186 degrees Fahrenheit. However, during a flyby, the Galileo spacecraft detected a dense stream of atomic hydrogen escaping from the moon's thin atmosphere. This indicates large amounts of oxygen locked up or hovering over its icy surface. Atomic hydrogen, being the lightest atom, escapes Ganymede's weak gravitational field, while atomic oxygen stays behind. Researchers suggest Ganymede could have as much oxygen on its icy surface as Earth has in its atmosphere. Could Ganymede have everything necessary for life in its subsurface oceans? Some scientists think the pressure at the base of any ocean here would be so high it would turn to ice. But a mission is needed to find out more. However, this moon isn't the best candidate for life. Another moon orbiting Jupiter, called the most habitable place inside our solar system by some scientists, is Europa. Europa is an icy white moon with brownish streaks on its surface and an icy crust that could be 2 to 20 miles thick. It has the smoothest surface of any object in the solar system, without any mountains or craters. Beneath the icy surface lies a vast underground saltwater ocean, possibly twice the volume of Earth's oceans. Europa is very cold, with an average temperature of -260 degrees Fahrenheit, keeping the icy crust as hard as granite. Could life still exist here? It's possible. At the dawn of the space age, it was believed all life depended on the sun, and any object too far from a star would be a frozen ball of ice, unable to support life. However, discovering thriving ecosystems at the bottom of Earth's oceans, relying on hydrothermal vents, changed that belief. We now know life can survive completely isolated from the energy of a host star like our Sun. This is important because Europa could harbor simple microbial life in liquid oceans beneath its icy crust, possibly surviving off hydrothermal vents. How do we know Europa likely has liquid water needed for life? The Galileo spacecraft, which flew over the moon in the 90s, found evidence of a vast, deep, dark global subsurface ocean. Despite the moon being expected to be a solid ball of ice, the water doesn't freeze completely due to powerful tidal forces as Europa orbits Jupiter. These tidal forces cause Europa's core to generate heat. Scientists are excited because this global ocean is thought to be in direct contact with surface ice in the moon's silicate mantle, creating a habitable environment with liquid water, an energy source, and minerals and nutrients necessary for life. Some bacteria, or extremophiles, like tardigrades, can survive extreme environments. Europa's hidden ocean might have such life forms. Between 2014 and 2016, researchers obtained evidence suggesting liquid water on Europa. Hubble Space Telescope images showed huge geysers of water vapor, some 62 miles high, erupting from Europa's South Pole. Although some researchers are unsure, we'll find out soon enough. NASA plans to send a probe to Europa by 2025. The spacecraft, called the Europa Clipper, will explore whether this icy moon has conditions suitable for life. The $2 billion solar-powered probe will fly by Europa 40 to 45 times, using high-tech instruments to study the moon's icy shell and the ocean beneath. Will it find life? Only time will tell. What about Jupiter's moon Callisto? Could life exist there too? Callisto is the second largest Jupiter moon and the third largest moon in the solar system. Almost the same size as Mercury, with a surface temperature of -218 degrees Fahrenheit. Once thought to be a dead moon due to its ancient cratered surface, Callisto has more craters than any other object in the solar system. A heavily cratered surface suggests geological processes are probably dead. However, Callisto orbits too far from Jupiter to be affected by the gas giant's magnetosphere and heavy gravity. Still, Callisto may have an underground ocean, with its icy crust acting like a cosmic blanket insulating this ocean. Whether this ocean could hold life is unclear because the surface is so old. Only a probe can determine what's happening on these icy moons. NASA and the European Space Agency are building the Jupiter Icy Moons Explorer, or JUICE, planned for launch in 2022 and a 7.6-year cruise to Jupiter, arriving in 2029. The James Webb Space Telescope promises amazing potential to find habitable exoplanets, but the JUICE probe will carry the most powerful scientific payload ever flown to the outer solar system, including 10 state-of-the-art instruments. Additionally, an experiment using the spacecraft's telecommunication system with ground-based instruments will be conducted. During its 3.5-year mission, JUICE will make 30 observation overflights of Callisto, Europa, and Ganymede, studying them closely by examining their gravity, magnetic interactions, and checking for liquid water under their surfaces. It will investigate whether these oceans might hold organic components necessary for life, or even life itself. Another moon, though not orbiting Jupiter, has been drawing researchers' attention lately. In 2019, NASA revealed the ocean on Saturn's moon Enceladus contained the building blocks for life. This vast ocean, about 6 miles deep, lies under an icy crust 19 to 25 miles thick. Cassini spacecraft images showed huge plumes of water vapor erupting through cracks at Enceladus' South Pole, indicating an underground ocean. NASA's analysis found water vapor, ice, salts, methane, and organic molecules in these plumes. A new study shows Enceladus is geochemically complex, with carbon dioxide controlled by chemical reactions on the seafloor of its interior ocean, increasing the moon's chances of harboring life. On Earth, oxygen-breathing creatures use energy in organic matter to create carbon dioxide and water, while oxygen-breathing microbes can metabolize hydrogen to create methane. Cassini detected methane, carbon dioxide, ammonia, molecular nitrogen, and molecular hydrogen in Enceladus plumes. Molecular hydrogen indicates free energy in Enceladus oceans. Cracks in the ice where plumes erupt have temperatures warm enough to suggest the ocean is heated by the moon's core, with hydrothermal vents similar to Earth's ocean vents, which are hotspots for life. A team of scientists now wants to send a probe to Enceladus called Orbalander, costing $2.5 billion. The probe would orbit Enceladus for 200 days, which is challenging due to Saturn's giant gravity field. Orbalander will fly through vapor plumes, funneling them into science instruments at high speeds. The probe will then convert to a lander, with 2 nuclear power sources keeping it running on Enceladus' surface for up to a year and a half while sending data back to Earth. The chances of finding life seem more possible with these exciting missions, promising amazing discoveries. Thank you for watching and see you next time. Stay tuned here for updates.